King Angelo E. Combustion Quiz number 3, number 1. An oil engine takes in air at 1.10 bar, 20 Celsius, and the maximum cycle pressure is 69 bar. The compression ratio is 18:1. Calculate the air standard thermal efficiency based on the dual combustion cycle. Assume that the heat added at constant volume is equal to the heat added at constant pressure. So, at dual combustion cycle, we need to draw the diagram first. Diagram is needed to understand the problem more. It states that the problem here is 1.01 bar and the maximum cycle pressure is 69 bar. V2, V1. Then, given is air. P1 is 1.01 bar. T1 is 20 Celsius. We need to convert it to Kelvin. Equals to 293 Kelvin. And the compressor ratio is, or RK equals to, or RK is also is to 1 V1. V over V2 is 18. Then, the problem, there are conditions stated. That condition is, assume that the heat added at constant volume is equal to the heat added at constant pressure. So, our main objective is to find the efficiency. So, to find the efficiency, first we need to solve for the temperatures. We need the temperatures so that we can use it in the heat formulas. So let's see. Now we have T1. So for T2, for a perfect gas, T2 over T1, formula is T2 over T1 over V1 over V2 raised to K minus 1. So, we have compressor ratio here, 18, and the proportionality constant K. We have here a table A, that one, got constant gas and specific heat. Air is 1.4. So 1.4 minus 1 equals to, by solving, calculating it, 3.1776. Now, by finding T2, we will T1 RK equals to give, we have the formula, the givens, 293 times the 3.1776 for T2 equals to 931.0368 Kelvin. There we go, we have T2. Next, for T3 in the process 2 to 3, here process 2 to 3, which is isometric, which means V2 equals V3. Solving for T3, P3 over P2 equals to T3 over T2. Now, P3 or times T2 over P2. Let's check. We have P3 given here, 69 bar. T2 is 9. P2, we don't have P2. So to find P2, let's go back to the compressor ratio. P2 over P1 equals to V1 or V2, which is the compressor ratio, is 18.4. Solving for this, we will get 57.1980. So for P2, P1 RK 1.4, we already got it here, so values bar 57.1980. So we'll get P2 as 57.77 bar. Now we have P2. Let's put the givens too. P3 is 69 bar. I will not put the units because we already know we are using pressure for bar and Kelvin is for temperature. 69 times the temperature to 931.0368 over P2, 57.77 equals calculating it. T3 is 1112.0224 Kelvin. Now we got T3. Next is T4. Now we have condition here. Says that heat added at constant volume is equal to the heat added at constant pressure. So heat added at constant volume equals to heat added at constant pressure. So we will get how formula for is CV T3 minus T2 equals to MC Cp, constant pressure, T4 minus T3. Cancel. So, we will use the table again to find the Cv and Cp for air, constant pressure and constant volume. So, for for Cp, 0.7176 kilojoule per kilogram Kelvin, and Cv is 1.0044 kilojoule per kilogram Kelvin. Now, since we have the Cv and Cp, we have all the givens here except for T4, because we are going to get T4. Cp 0, Cv 0. 0.7176 times 75 correct. Cv is here, this. Cp is this. Sorry for the typo. Now 122.024 minus 931.0368 equal to the constant pressure 1.0044 times T4 equals to 1112.0224 T3. Now, by fixing the equation 0.7176, and by calculating this, we will get 180.9856 over 1.0044 plus 1112.0224. Now, by calculating it, we will get T4 equals to 241.3287 Kelvin. Now T4. Now for T5. Solving for T5. For T5, in the process 3 to 4, which is isobaric. Now we have volume ratio. Since volume ratio equals to V4 over V3 equals to T4 over T3, we have T4 and T3. Now 3287 over T3 is 111.0224. We will get the volume ratio is 1.1162. Therefore, V5 over V4 equals to V1 over V4 equals to V1 V3 over V2 V4 equals to compression ratio over, this is RC, volumetric volume ratio, RV. We have 18 over the 1162 equals 16.1261. This is for this V1. And then for T4 over formula is T4 over T5, V5 over V4 raised to K minus 1. So we have this, we have the value of V5 over V4, which is 16.1261 raised to 1.4 minus 1, which is K. 1.4 minus 1 equals to 3.04. Now, T5, the value of T4 is 1241.3287 over 3.04 T5. By calculating it, we will have 408.33 Kelvin. Now, for T5, T4, T3, T2, and T1. This is another pattern here. Now we have that. We're looking for efficiency. So for the efficiency, we have the formula is summation of Q over Q1. Now, Q1 or heat supplied. So heat supplied, we can solve for heat supplied equals to CV T3 minus T2 plus CP T4 minus T3. Why? Because right here is Q added and Q rejected, heat rejected. And then since without forgetting our condition, constant volume is equal to the heat added at constant pressure. Now we'll derive this formula Q1. Now solving for this, Q1 equals 2 times the CV is 0.7176 times the T3 is 1112.0224 minus T2 is 931.0368 Kelvin equals, solving for this, we will get 259.7505. Unit for heat is kilojoule for kilogram since we didn't use mass, and there's no given mass. And next is, by the way, summation of Q is Q1 minus QR, or Q1 is also equal to Q added for QA. Now for Q heat rejected, CV, heat rejected is CV times T5 minus T1. So solving for this, 0.7176 times T5, 8.33 minus T1 is 293 Kelvin. So solving for this is 82.76 kilojoule per kilogram. Now we have Q1 or QA. Let's go to this last formula to solve for the efficiency. QA is 259.7505 minus 82.76 over 259.7505 equals times 100%. We will get 68.13% or 0.6813. So that's the answer for number 1. Thank you. Next.